Greetings, Earth Science students. This is a video study guide for the ES4 Minerals and ES5 Rocks unit, for which you've got a test coming up. So let's say you've got an unknown substance and you're wondering, is it a mineral? How do you know if it is? We'll think about zinc, or SINCC. It's got to be solid. It's got to be inorganic. It's got to be naturally occurring. It's got to have a definite chemical composition. I'll talk a little more about what that means, and a definite crystal structure. Both of these things basically mean it's a pure substance. For crystal structure can be a number of different things, but for example, halite has a cubic structure. Halite is table salt, and that means there's a repeating pattern. The atoms arrange themselves into this cube formation over and over and over again. There's lots of other types of crystal shapes. You don't have to memorize them, but some of them are pyramidal, hexagonal, lots of different shapes. It just means there's a repeating pattern when we talk about crystal structure. Chemical formula means that it's the same atoms repeating themselves over and over again. Like for quartz, it's one silicon atom and two oxygen atoms, SiO2. Hematite, for another example, is Fe2O3. Iron oxide, two iron atoms, three oxygen atoms, repeating over and over again. And calcium carbonate is CaCO3. And these are three different examples of the major types of minerals. Quartz is a silicate containing silicon and oxygen. These are the most common minerals on the planet. Hematite is an oxide containing oxygen and a metal. Iron is a metal. And calcium carbonate is a carbonate, which means it's got this CO3 as part of its crystal structure. So once again, silicates are the most common element, or the most common mineral, in Earth's crust. Oxides and carbonates are also pretty common, but silicates are the most common. When you're looking for minerals in Earth's crusts, sometimes you find ores. Ores are certain minerals, ore-forming minerals. For these, we're talking about metals or gemstones, something that is has value, like a monetary value, and it's usually something that can be and is mined. Other minerals are rock-forming. Rock-forming minerals tend to mix with other minerals, and they're probably a little less valuable, although they will have some monetary value. So a few minerals and their uses include halite, that is table salt. The chemical formula for that is, NaCl, sodium and chloride. Graphite, which is used as pencil lead, diamonds, which are the hardest mineral, and they're used for drilling sometimes. Talc is the softest mineral, and it's used in baby powder. Copper is used in electrical wires. Mica is an electrical insulator. And pyrite is fool's gold. Those are probably the only ones you really need to think about for the test, although there's a few others in the notes that you could review as well. So let's say you have your unknown substance, the original thing we were talking about, and you are pretty sure it is a mineral, but now you want to know, which mineral is it? So you know you have a mineral, not a rock. But now you want to identify what mineral it is. You have to test its properties. And the properties of minerals include color. But color's not a great identifier for minerals because impurities can cause minerals to change color. For example, quartz comes in many different colors, but color still counts as a property you might look at. Luster, which is how shiny a mineral is or not, and you can use words like metallic, non-metallic, submetallic, as well as glassy or pearly or greasy, among many different words you might use to describe luster. It's just how shiny it is, how does light reflect off of it. Another property you might test is streak. For streak, you have an unglazed porcelain plate, and you take your mineral and you scrape it on the plate. And the color that pops up on the plate, that is the powder form of the mineral. And streak is not the same as color. You can have a mineral that's one color and it gives you another streak, like a mineral that is gold in color might have a gray streak, or a mineral that is black in color might have a brown streak. You might get a different color on the streak than you have when you look at the mineral. Another thing you might want to look at for what mineral do you have, a property you can test is hardness. Hardness, you use Mohs scale. And Mohs scale goes from 1 to 10, 1 being talc, the softest mineral, and 10 being diamond, the hardest mineral. And in the middle, there's some other ones. Quartz is a 7, gypsum is a 2. Every number has a particular mineral assigned to it. I'm not going to fill them out here, and you don't have to memorize them. What you have to know is that 10 is the hardest, and 1 is the softest. Anything that is higher on the scale can scratch everything below it. So diamond could scratch quartz, diamond could scratch gypsum, diamond could scratch talc. Diamond could not be scratched by any of these three. talc can be scratched by anything. This is called the scratch test. And there are some common household items you might use for the scratch test. So a penny has a hardness of 3, a glass plate has a hardness of 5, and so on and so forth. So a penny could scratch talc, but a penny could not scratch quartz, for example. You also want to look at density. A lot of times they refer to density as specific gravity when they're talking about minerals. Density is mass divided by volume. Mass, you would use a digital scale or a triple beam balance. Volume, for a mineral, you'd probably use a graduated cylinder and do water displacement, where you have a known volume of water. You drop your mineral on the bottom, and the volume raises in the cylinder. The difference is the volume of the item you dropped in there. If your mineral was shaped like a perfect cube, then you could do length times width times height. That would also give you volume, but usually your minerals are shaped more irregular, so you would use water displacement. Another thing you got to look out for is cleavage or fracture. So when it's cleavage, like in the case of mica, you get these perfect flat layers, or maybe you get a cube shape that breaks apart. You're testing how it breaks apart. If it's fracture, it tends to be kind of irregularly shaped. When it breaks apart, there's no specific pattern. For mica, it breaks off in flat layers. Halite has a cubic shape, it breaks into cubes. This is because of weak bonds in mica between the flat layers. Wherever you have a flat side, that's where the weakest bonds were, and they broke apart in your crystal shape. So mica has flat sheets because of weak bonds between the layers, for example. I think that's going to do it for minerals, and this video is getting a little bit long, so I'm probably going to post a separate one for rocks.